Welcome back to this series, everyone. We are back with another tutorial, and this is the final part of the Exponents and Radicals series. In this video, we are going to be going over rational exponents and radicals. So the first thing we're going to go over is simplifying powers with rational exponents, but just a very quick review because this is going to be the foundation of everything we're about to learn. So just make sure you know how to add and subtract fractions, and in case you don't, let's go over a really quick example, even though I'm sure you know. If you have 3 over 8 plus 3 over 4, you have to find a common denominator. So the common denominator between 8 and 4 is 8. So this, just multiply it by 1, and you get 3 over 8. This you have to multiply 4 by 2 to get 8, so you have to do the same thing with the numerator. Multiplied by 2, you get 6, and then you just add the numerators. You get 9 over 8. The same thing would be with subtractions, except obviously at the end you would subtract the numerators instead of adding them. And then with multiplying and dividing, it's actually a lot simpler. You don't have to find a common denominator. You just quite literally multiply the numerator and the denominator, so you get 24 over 15, and then you reduce that. Know that 3 times 8 is 24, and 3 times 5 is 15, so that's your answer. And then with division, it's the same. Something to remember when dividing fractions is if, let's say you have like the same thing, 6 over 5 divided by 4 over 3, there's this thing to help you remember what to do with when you're dividing fractions, and it's keep, change, flip. So that means you keep the first fraction the way that it is, you change the division sign to multiplication, and then you flip the second fraction. So this gives you 6 over 5 times 3 over 4. So then you have 6 times 3 is 18, 5 times 4 is 20, and then you can reduce it. 2 times 9 is 18, and 2 times 10 is 20. Okay, and then it would be the same thing if you have, let's say, 6 over 5 divided by 3. This literally just means 3 over 1. And then you would do the same thing. Keep, change, flip. And just a fun fact, whenever you flip a fraction is the reciprocal. So 1 over 3 is the reciprocal of 3 over 1. Or 12 over 5 is the reciprocal of 5 over 12. Now, we're going to learn how this actually applies to simplifying powers, and this is where you have to combine your knowledge of exponent laws and also how to multiply and add, divide, subtract fractions. Okay, so let's just do some questions. That's really how we're going to learn how to apply this. So if we have x to the power of 2 over 4 times x to the power of 1 over 4, as you know, or as I'm hoping you know from your exponent laws, when you multiply, you add the exponents. So this actually becomes x to the 2 over 4 plus 1 over 4. And now I'm sure you can see why it was important you knew how to add fractions. So we don't actually have to find a common denominator because they have the same denominator. So just add the numerators, and that gives you x to the power of 3 over 4. If we have y to the negative 1 over 10 divided by y to the power of 2 over 5. Since we're dividing, these actually subtract, so that gives you y negative 1 over 10 minus 2 over 5. And then this is where you have to find a common denominator and everything, so let's just do it right under here. We have negative 1 over 10 minus 2 over 5. Obviously, the common denominator is 10. So this stays exactly the same. And 5 times 2 is 10, 2 times 2 is 4. So negative 1 minus 4 is negative 5 over 10. And then we can simplify this to negative 1/2. So our final answer here would be y to the power of negative 1/2. Another example, say we have x to the power of 1 over 2 times, or all to the power of 2 over 3. So our exponent laws tells us that this means x to the power of 1/2 times 2 over 3. So we just strictly multiply, and this gives us x to the power of 2 over 6, which can be further simplified to x to the power of 1/3. Let's do one last one. So if we have a squared over b, let's say this is all in brackets, and this is all to the power of negative 1/2. As we know, negative exponents, if we want it in positive form, we just flip it. We just flip what's in the brackets. So this is the same thing as b over a squared to the power of positive 1/2. And we know that we first have to apply that power into everything in the brackets. So this becomes b to the power of 1/2 divided by a to the power of 2 times 1/2, and that gives us 2 times 1 is 2 over 2, so this just equals b to the power of 1/2 divided by a to the power of 1, which is the same thing as a. So this will just simplify to b over 1/2 divided by a to the power of 1. And it stays like this because you have to remember bases are very important. Since b and a are different bases, you can't simplify this any further. Part 2 of rational exponents is evaluating powers with rational exponents. What does that actually mean? Okay, so x to the 1/2, it's kind of confusing because it's like, well, x squared means x times x cubed means x times x times x, but what does x to the 1/2 mean? Like, you multiply half of x, like, what? And in a way, it's kind of true, because when you have a fraction as an exponent, that's where radicals are involved. When you have x to the 1/2, that actually means square root. That means the square root of x to the power of 1. Okay, so similarly, x to the 1/3, or x to the power of 1 over 3, that means cube root of x to the power of 1. Before we go over this, if we have x to the power of 1 over n, this just means the nth root of x to the power of 1, because it's 1 over n. So this is n root of x to the power of 1. X to the power of negative 1 over n. Take a second to guess what you think that would be. Just pause the video and write down your guess. This actually means, so as we know, negative just means it's a denominator. So that means 1 over n root of x to the power of 1. Alright. So let's start off a little bit more simple. Let's say we have 4 to the power of negative 1/2. Let's start by writing this as powers with positive exponents, okay? So the positive version of this is 1 over 4 to the 1/2, right? Because this is a negative, this is the positive version. Now, to write this in radical form, we just learned that it's 1 over 1/2 means square root of 4 to the power of 1. And that, if you want to simplify it, or evaluate it, you know what the square root of 4 is, and it's 2. So that just gives you 1 over 2. Let's say we have 25 over 36 to the negative 1/2. Let's start by writing this in positive exponent form. So we just flip what's in the brackets. So now we have 36 over 25, and that whole thing to the power of 1/2, which is now positive because we flipped it. Now, to write this in radical form, you have to remember, this is why I keep reiterating that you have to pay very close attention to brackets and what exactly that exponent is being applied to. That half is being applied to everything in the bracket. So this means 36 to the power of 1/2 over 25 to the power of 1/2. Now in radical form, as we just learned, this means square root of 36 over the square root of 25 to the power of 1, of course. And if we were to evaluate, square root of 36 is 6, and the square root of 25 is 5. So that's our final answer if we were to simplify it. This is where it gets a little bit interesting. What if you have a question like this? What exactly do you think that means? And like I said before, that bottom, that denominator in the fraction of the exponent is the root. So we know this is going to be cube root. But where does that square go? And the answer is, that is the power that is being raised to that base. So before, when we had 1 over 2 or 1 over 3, that's why it was always the root of x to the power of 1, or 8 to the power of 1, or 6 to the power of 1. But since it's 2 over 3 in the exponent, it's 8 squared, and not 8 to the power of 1. So then this ends up giving you cube root of 8 squared, which is 8 times 8 is 64, the cube root, and that gives you 4, because 4 times 4 is 16, and 16 times 4 is 64. So now let's say we have 27 to the power of negative 2 over 3. Take a moment, pause this video, and write down your guess of what you think it'll be. Let's pay attention to the negative sign first. So this means it's 1 over the cube root of 27 squared. This simplifies to 1 over the cube root of 27 squared, which is 729, and then the cube root of that is 9. So your final answer would end up being 1 over 9. Now, another thing to remember, if this was one way of doing it, but you could have also, say we have 1 over cube root of 27, you could have ended up squaring this entire thing and you would have gotten the same answer. You would have gotten the same answer. So if you found that this was easier, let's say you're like, well, I don't really know what 27 squared is, and I don't really know how I would figure out what the cube root of that is. But you'll see this, and you're like, the cube root of 27 is 3, because 3 times 3 is 9, and 9 times 3 is 27. So you're like, okay, I know what the cube root of 27 is. You could just end up squaring this instead, and it will give you the same answer. So that's an important thing to remember, is you could cube root, you could have this, the denominator of the fraction be the cube root, and the numerator be the power, but you could also raise that power to everything including the cubed root. If you have x to the power of 2 over 3, you could write it like this, or you could also write it like this. If you find that whatever is in here is easier to evaluate, you can evaluate that first and then raise it to the power. Alright, let's say you were given a question like this, 49 to the power of 0.5. You're like, bruh, I don't know, like, I just learned fractions. How am I supposed to work with decimals? Well, it's actually quite easy, because you know that 0.5 means 1/2, right? Because 0.5 means 50%, which means half. That's why it's very important that you know little conversions like this. You can also, if you're allowed calculators, you can put it into your calculator, 0.5, and ask it to turn it into fraction form, and that will give it to you, you know? You're like 49 to the power of 1/2 just means square root of 49, which is 7. Now, the very last thing that I'm going to briefly touch on for this last part of this Exponents and Radicals series is radicals. So I think it's important for you to know, like, if your teacher asks you on a test, convert from power to radical, and you don't even know what exactly that means, then all of the math that you've learned is irrelevant. So if you're converting from a power to a radical, it would look something like this, because this is in power form, 49 to the 1/2, and this would be radical form. All right? You're turning a power into a radical, and this is a radical. All right? Same thing, just the opposite of converting from a radical to a power. If you have square root of 16, which is a radical, and you're asked to convert that into a power, this just means 16 to the power of 1/2. All right? Now, this is where things get a little bit more interesting. If you are asked to convert an entire radical to a mixed radical, you need to know what that means. So if you have, say, the square root of 24, that is an entire radical. Okay? There's nothing else to really be done. That's just a radical. But if you have 2 times square root of 6, that is a mixed radical. Okay? So now that you know what exactly those two different radicals look like, let's find out how you actually convert an entire radical into a mixed radical. So let's say you're given this square root of 24 as your radical, and you have to convert it into a mixed radical. Now, you have to list different radicals that make up the product of the square root of 24. And what this looks like is if you have square root of 1 times square root of 24, because 1 times 24 is 24, you have square roots here and here and here, so that works. You could have 8 times 3, the square root of 8 times square root of 3. You could have square root of 2 times square root of 12. You could have the square root of 6 times the square root of 4. And then you're like, well, I actually can simplify this. Once you reach something that you can actually get a whole number from square rooting it, that's where you're like, okay, this is where I can turn this into a mixed radical. Because 24, you don't know what the square root of 24 is. Or even if you do, it's not a whole number. So you can't really break that down. Same thing with 12. You're like, I don't know what the square root of 12 is. I don't know the square root of 8 is, or what 3 is, you know. But you do know that the square root of 4 gives you a whole number. So then that gives you the square root of 6 times 2, because the square root of 4 is 2. And that is your mixed radical. And now let's just quickly go over converting mixed radicals to entire radicals. And that follows the same pattern, but in reverse. So let's say you have 5 times the square root of 2. You just square the part of this that isn't square rooted. So then to figure out the entire radical, have 5 squared times the square root of 2, which you just leave that as it is. 5 squared is 25. And since you just squared the 5 to get 25, you put that into the square root. Then you have times the square root of 2. That stayed exactly the same. And then you multiply the two values in here, and you have 25 times 2 is 50. And then that gives you your entire radical. And you know this because if you were to break this down into a mixed radical, you would end up here. because you break this down, you're like, okay, like, I can do 50 times 1, I can do 25 times 2, right? Then you're like, okay, 25 times 2, I can't break down 2, but I can find the square root of 25, and it's 5 times square root of 2. Alright, so that concludes our final video on the Exponents and Radicals series. I really do hope you guys found this educational, and I'll be back with more math tutorials, so I'll see you guys next time.